me rewrite my tip here. There's a little hint here. Well, okay. Let's start with the negative sign in front. So the negative sign is in this A spot. So if it's negative, it's a reflection. If there's another number there, it would be a stretch or a shrink. So we're going to reflect the parent function across the x-axis. All right, and how about the plus 3 that's underneath the radical bar in the H spot? What are we thinking about that? Fit into the earbud. Anybody? 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 What do you think that plus 3 is going to be on there? What do you think? Libby? You want to go? Hard enough from Libby? Love 3. Okay, so if there's a number underneath that's going to move something horizontally, that means right or left, opposite of how it looks. So this is going to shift everything left 3 units. Alright, now we also have a plus 2. What's the plus 2 going to do? Eager? Well, this one's not opposite, so it's going to go up. So this one is, yes, up or down, but it's plus, this one goes up too. Alright, good. So now we have all our transformations. We're going to graph this one first. And then we're going to move this one around. Okay, so I have to think. I want to flip it, I want to left it, and I want to up it. So it's going to be kind of in that second quadrant there. I'm going to go low on there. And I'm going to go 1, 2, 3, 4, 5, x-axis, 3, 4, 5, y-axis. Okay, so starting with this one, 0, 0, 1, 1, 4, 2. I could even put in 9, 3 if you make it long enough. 6, 7, 8, 9. Okay. There it is. We talked about one of the most important characteristics about the square root graph is that it doesn't have 2 arrows. It's got an end, it's got a dead end, it's got an arrow going one or the other. So don't put an arrow here. So does anybody remember why there's a dead end in the square root graph? I'm calling somebody. You know, Luke? What's the dead end for the net? Right, because this square roots, you can't square root negatives. This is imaginary numbers. We have a dead end, and we have an arrow. Okay. So now we have to move left, up, and flat. Do you like moving things that much, or do you want to make a new table? Would a table be easier or a move easier? Raise your hand if you just want to move it and not make a table. Raise your hand if you think a table would be easier to plot points. No idea. So I had one hand raised for just moving it. So I'm going to move it, and then I'm going to go to the table, and you guys can decide, yeah, man, the table was easier. Okay. Oh, it's not working out for you? Actually, that's cool. All right, so here's my hint. It's really a tip more than a hint or a fact. The HK value is the end point. So the value in h is a -3. The value in k is a 2, so I can go to -3, 2, and that's going to be my new end point. So this guy here and this guy make an end point. Here we go. -3, 2. That's going to be where my new one has a dead end. And there's no stretch or shrink, so technically from here I could just, copy paste. Just move every point. Yes. No, it's not because of that. It's just because, like, in the model, there's a minus sign. So you put a negative and it goes positive. It's like opposite. That one's opposite. This one is not. But if you put a negative in there, it's positive. Right. So I kind of just want to go over 1, up 1, over 4, up 2, and make the same thing. The only issue is that it has to flip over. So I have to think like 2 steps at a time. So normally if there was no reflection, I would go over 1, up 1, over 4, up 2. However, this is reflected, so I have to go the other way with it. I'll go over and down, over and down. I could even go over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 3. Why does this look so different? That's fun. And there it is. Sorry, so I had to go left, up, and then flip it over. 3 moves. So I think that's tricky. See, it took me quite a bit of practice to be able to just move it and flip it, and I have it memorized. So the other way that I was suggesting before is just to make a new table. I don't think you guys are gonna love this way either. And this would be just for this particular, I'm gonna make it -1 dot. I like to put the product dot in there. X plus 3 plus 2. So, and then you gotta kind of think outside the box. About the goal is you want to create the square root of 0, the square root of 1, square root of 4, and the square root of 9. So you think, like, what would make that equal 0? What would x have to be to make it 0? -3. So then you would do -1 times -3 plus 3 plus 2. And then how could you possibly get a square root of 1? What number would you plug in to get a 1 in there? Somebody besides Luke. How'd you make a 1 in there? What x value would make a 1? Jared, you know? Jared, you got it? 1? Well, are you thinking about the final answer? No, I want to put something in here and get a 1 right here under the radical. How would I get a 1? What plus 3 is 1? -4 would make -1. It's a good guess. There you go. Okay, -2. Okay, now I'd love to actually have a 4 in there because I can actually square root 4. What number would I plug in to get a 4? 1. And now lastly, how would I create a 9 under there? 6. And that would give you points. If it's hard for you to come up with this green line, you can also come up with these numbers. Let's do the math real quick. So this would be -1 times the square root of 0 plus 2. -1 times the square root of 1 plus 2. -1 times the square root of 4 plus 2. And -1 times the square root of 9 plus 2. So do you guys see what I've been trying to create? I'm trying to create 0, 1, 4, 9. Get it with those numbers. See if you think kind of abstractly ahead. So that's 2, 1, 0. So that -3. -1. So now I have ordered pairs. I have -3, comma 2, -2, comma 1, 1, comma 0, 6, -1, and I could just plot these points. That being said, who thinks it's easier to just try to copy it, to count over and up and copy the shape without a table? Who thinks it's easier to come up with values that square root and make a full table? Okay. A couple of people are on board with the table. More people are on board with moving. The table shows a lot of comprehension. Being able to think about all those numbers together. So it's a very good practice. Moving it shows you understand transformations. Let's say you don't get any of it. You don't have any idea what I'm talking about. Go ahead and make any table of x values and get decimals. Okay, and graph using decimals. I'll give you points for that. It's not as good as getting integers, but if you have to plug in, let's say you try 5 or 4 and you get a decimal on a calculator, you plot it correctly, you get a general shape, I'll give you some credit for that. So you can always go with decimals. So think for a minute about domain and range of the green function. Let me label that. That one's the g of x. The red from Friday, see after that. Domain range. Telling somebody else about domain and range. Lewis, you want to try domain and range? No? Do you remember what domain is? Is it x values or y values? Totally checked out. Brandy, domain x values or y values? Domain z x values. Range is y values. Cleo, it's a domain. What x values did we use to make this green one? Let me ask you this. Did we, for instance, use x as -5? We didn't. Our green line doesn't even go over here. Did we use x as -10? Look, it's just where the table starts. So it starts at -3 and it goes up. Right? It's also where this, I identified HK here. It's also that number. This is the domain number, and this is the range number. I'm going to write that out right now for you. Domain number, range number. Does that help? All right, so our domain starts at -3 and goes up through infinity, and our range starts at 2 and it goes down towards -infinity. This is a full review from class on Friday. That's everything we covered in class on Friday. It's even a little more. So 20 minutes. Here's the review. I'd like to see you go back and remember what we did Friday. So open your books to page 447. Let's see see what we got. Yeah, go ahead. Did you at least one class? I do 1 point per graph. It's 4 graphs. You did 4 points. You did 1 point. So, here's your dot. Take it on first. So, yeah. There you go. Oh yeah, this is our first 5D. Just give it back. It's like recorded in like 3D. Did it feel like though you can just pull it back? It's recorded 2 days ago.
Yeah, this is our first 2 day weekend. Yeah. That's great. Like, really a 3 day weekend.
Yeah. But I think we have a really long time until school. I'll put like a calendar. What's that right there in February, Jimmy? Can you tell? President's in February. Presidency. It's like a full week of bad values.
That's cool. Something survey week. It's like FTE survey week.
Oh gosh, that's what we have to take perfect attendance. So it's in the end of March this spring. What's the January? There's 1 day off in February and the end of March. We do a whole week ago. This is so much knowledge to suck into your brain up the next several weeks. Just learning new things all day. This is so lucky. What? People feeding you information. Once you get older, nobody tells you anything anymore. You have to go find the information yourself. It's way hard work. There's nobody sitting telling us things. It's a bar. It's like figure out, how do I want to do this right now? What choices do I want to make? Nice grass. There we go. That's what you're doing. Good job. Something about security. But I think the word that you're pretty thorough. Well, what I mean by example is there's over 2,000 devices like online.
Because you're looking at the ball.
It's your great. Right, good too. Had wings. That's too very good.
How many did you do?
Oh, just got 2 more. So I got 2 plates. I ate 2 plates of wings.
Summit class? This is class. There's one the other way, huh? Supposed to know. Doesn't go.
Oh, nice.
Hey, how you doing? Different, huh?
Yeah.
So he is negative 6?
For 9. What is right or rolling? I don't know what the rules are.
Why isn't it just working right now? Look at right here, Vantress. Look, the -1. You see the dot? Let me zoom more. The -1 really isn't affecting what's under here. Alright, so if the negative is outside, you can still square root. Yeah, that's like a -1. You can think about that like -1 times that thing. Do you hear what I'm saying? Alright, you waking up? You waking up? You getting here?
What are the rules?
What are the rules? The rules about square root.
Yeah, it says write a rule for T described by the transformation of the graph of F.
It's an equation.
Oh, okay.
Alright, you guys, so here's our notes for chapter 5.4. We're not done with 5.3, but you're asked to learn cube roots and square roots kind of side by side. So now we're gonna do the exact same thing, but our radical is gonna have a baby 3 in it as an index. So you have to know two parent functions. You have to know this one, 0, 1, 4, and 9, numbers that square root. But then you also have to know what to do if you're challenged to graph a cube root. So for a moment, before I tell you, I want you to try to think about what numbers could be plugged in for x here, where you would get out integers and not decimal. So we're transitioning to cube rooting from square rooting, and then tomorrow we practice both. So it's not like square rooting's over. What do you need? Change? Are you asking about what the cube roots are? Okay. That's the right question. What are the cube roots? I think you come up with it yourself. I don't know how to tell you. If they just you take the horse to water, the horse you're drinking the water. This is that moment. Like the 0 and 1. 0 and 1 work. Yeah. 0 and 1. Alicia's gonna give us a look there. I'm gonna 0 and 1 both work. 0 other than that, all of the other values are different. So we need to come up with some other number that will cube root. What the heck is a cube root? Jake, you got it?
27.
Ooh, 27 cube roots. Where'd it go? 27 is a really high number. So the math answer. What's the cube root of 27? 3. So we can graph 27 comma 3. We're in it. That's a big clue. Can anybody come up with another one?
8.
8. We're really in it now. The cube root of 8 is 2. I don't want to go any higher. I actually want to go lower. Can anybody? I got 1. You're right. 1 works.
-4.
4 doesn't cube root. 4 is square root. All right. Could we put negatives in this table? Do negatives cube root? Yes, they do. We can't do negatives in square root, but we can do negatives in cube root. So yeah, let's do the negatives. The cube root of -1 is -1. What's another negative we could do? -8. The cube root of -8 is -2. And do you know what I'm talking about right now? I'm talking about the opposite of -2 is the third power, -8, cube root, -2 is equal to 4, times 2 is 8. So this is our -8, -2. And -1. This is our table for our cube root function. It's way different than the square root function. So I'm gonna so up here with square root, down here is cube root. If you can see that, the cube root parent function goes -8, -1, 0, 1, 8. Because these numbers will cube root into integers. And of course you could go to 27 and 64 and all that too. So you're going to want to memorize this guy. Right at the same time you're memorizing this one. Work out the brain here. Make you memorize numbers. Oh, what will it look like on graph paper? I can't wait to find out. Let's graph it. Yeah. You're excited too? No. You're like, yes. Right. What is this gonna look like? It's gonna look like an X. Anthony already knows this. He already knows graph. I'm tempted to go by 2. But I'm gonna start with 1. So 1, 2, 3, 4, 5. That's a 4. That's a fail. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. X-axis. 1, 2, 3, 4, 5. Y-axis. 1, 2, 3, 4, 5. 6, 7, 8, 9, -10. X-axis. That's what we needed. We needed a lot of music in here. Thank you. Whoever had the insight can play that jam. Right on. Okay, so now it goes through the origin, as most parent functions do. It goes to 1, 1, but now we have to go all the way to 8, cube root 8 to get up to 2. -1, -1, -8, -2. Here's the S shape. Anthony called out. What did he call out? Looks a lot like the square root, but instead of an end point, we go all the way to negatives because negative numbers can be cube rooted. So all of your odd radicals have arrows going both ways, while your even radicals have like a dead end and an arrow going. now I'm gonna do domain and range. All the numbers. How many people watched the Bucks game yesterday? Anybody? The football game? Playoffs? That many? I was so public in the middle of the Sunday. Was it yesterday or Saturday? And there was nobody there. I was like, where are the people? All the people were watching their football there. How many people in this football game was on in their homes yesterday? We're not less than a
It was my way to end the game. Anywho, it was better than I thought it was. Tough though.
Any questions about this? Does anybody want a picture of this? Go ahead, take a picture before we start the assignment. We got 12 minutes to finish this assignment. Let's do it. I got goals. Let's do it.
You gotta start reading like reset and stuff.
This is the assignment here. It's numbers 1, 3, 7 through 10, 27 through 30. I'm astonished. It looks longer than what I normally assign. But the truth is, only 2 of these are graphs. The rest of them is just like talking about shifts and moves and transformation. So it's 2 graphs, and the rest are not graphs. So it does look like a lot, but if you can get your 2 graphs done before you leave here, the rest is less work. Number 1. What do we think this minus 4 under this radical bar is going to do to this graph? We're going to move it right forward. Did it. Alright guys, so, and if you have your own graph paper, again, this is easier. Well, you're going to start with this table, and then you're going to count every point to the right 4. So you're graphing this cube root function, moving it right forward. Where'd it go? You know what I mean? You can figure this out. You can do it other. I think maybe go by 2s on your x-axis. I'll set it up. This is what I did. I went right off to the margin, and then I think I went here. I'm trying to go right. Yeah. And then I went 2, 4, 6, 8, 10, and 12. -2, -4, -6, -8, -10, -12. And then you don't have to go very high for this. I'm just going to go 1, 2 on the y-axis. And then that's helpful. Carson. Hey, Yeah, Megan. Look, nothing. Cousin. How do you do that? You should read example 5 about the elephant. You're gonna see too. It's fascinating. The mathematicians have figured out using a cube root function how to find the height, how to find the age of an elephant based on the height of their shoulder. That relationship is a cube root function. You guys say, why do we do this? Well, how would we know how old the elephants are if we didn't know cube roots? It's crazy. A lot of like zoologists and animal studiers, they do a lot of math. They have to interpret a lot of graphs and statistics. What's that? Yep. All right, so I'm gonna start with I'm gonna put this one the pair function on every one of my graphs. So it's 0, 0, 1, 1, 8, 2, negative 1, 1, negative 8, 2. Yeah, this is the pair function. It's got a nice little curve in there. It's an S shape. That's a cool looking picture. The software that makes graphic designs, that's what they're doing. They're doing this. Okay, moving on. Now I'm gonna just count right forwards and put it at. And here's the new one. What you'll see is that the ends kind of end up coming together. The main place you can see the 4 is just in the center. So that's where I really look when I'm like grading your graphs. I kind of look and I count what's the gap there. Did they have a gap before in the center? Because in the ends it's really difficult to see. So you should see 4 unit shift. What's this like? Yeah, no, that's.